The last example goes back to something we talked about last week. Last week I looked at linear equations. That's where you have an x and a y, whatever, and they're not raised to any powers. They're just to the first power. Those are called linear equations. And I looked at situations where you had two linear equations and two unknowns and talked about how to solve that system of equations to find an x and a y that satisfy both at the same time. Now, the reality of life is if you're dealing with things like that, then you probably aren't limited to two variables. And you have to know how to handle more general situations. So I'm going to take you through an example of that today. I'm just working with 3 by 3, but everything I talk about really could generalize to 4 by 4 systems, 5 by 5 systems, and so forth. And before I'm done, I'm actually going to kind of whip back in the matrix idea to show you that that's a way to solve the things, solve these systems. Okay. Let me give you an example, and I'm stretching here to give you examples that don't, you don't have to be a high-powered, even college grad to use. Let's say you inherited some money, and you thought it was wise. It was a pretty big lump sum, so you think it's wise to have someone kind of manage that for you. And I hope you never find yourself in this position, but your financial guy has left town with the records, and you are now wondering where your money is. You do know this about, so I'm kind of trying to go back and figure out what happened or where my money is. So you do know this, you have limited information. You know that you started with $30,000. You know that it went into 3 accounts, a 3% and 4% account, 2 accounts there. And the amount that went into those was proportional to the rates. So the 4% had a little bit more than the 3%. And then the rest of it went into kind of a high-risk account where you're getting a higher interest rate, but there was a chance that you might lose it. That's the one that wasn't at a bank. You're kind of worried about that one. So you can recoup from your tax forms that you earned in that first year. You earned $2,656 in interest. So the question is, all right, how much was invested at each rate? How much can I track to a bank? And how much is kind of floating around out there somewhere, probably a down payment for a condo for my financial advisor. So again, I've got 3 amounts. I'll call them X, Y, and Z. I'll do them in increasing order so we can keep them straight. And I have actually 3 equations. I know that the total of these 3 amounts has to be $30,000. Okay, that was the total inheritance, after taxes, whatever. And then the proportion business, well, a proportion is just an equality of ratios. The amount in the first account to the amount in the second account is 3 to 4. It's proportional to the rates. So you do the cross multiply trick, 4x equals then 3y, and I'll move everything to one side because I want to have this x, y, z kind of structure to my system, just for my own convenience. So there's my second equation based on that proportion. And then I have some information about the interest. 3% of the first amount plus 4% of the second amount plus 12% of the third amount. I know that that adds up to $2,656. So there is my last equation, and I went through and just multiplied everything by 100 to clear it of those decimals, clear it of the fractions. And so I do end up with some kind of large numbers here, but they're workable. We're okay. Okay? All right. Now, let me tell you what's going on with this. Give you a little background. A linear equation in 3 variables represents a plane in 3 space, and we live in 3 space. And a plane is just a flat surface. So in order to have a solution to the system, I've got to have 3 planes that all cross at one point. And that happens here. I'm going to illustrate this for you. The first plane, if I graph it, looks like this. And it actually kind of leaves my viewing rectangle here, my viewing box at the bottom. Okay. And then the second equation, the plane for that, I'm just graphing these things. I actually graph them with a piece of software called Mathematica. These 2 planes intersect, and the intersection of the 2 planes is a line, which I tried to color purple. I don't know if you can see that or not, but it's where those 2 planes meet. Okay. And now for this to have a solution, the other plane needs to come through here and cut through that line. And I do believe that happens. Here's the last one. I graph it. Yep. It comes through, cuts through that line. I actually try to draw a big black dot at the position where they all crossed. So this will have a solution. The problem is that I can't really get it very well from the graph. It's hard to tell exactly what it is from this graph. It's a 2D representation of a 3D graph, which is kind of ridiculous. So what I really need here is some way to solve it exactly. And I'm going to give you two methods. One is fairly elaborate on paper. The other is one that we can do with our graphing calculators and a little bit of knowledge of matrices. Okay, let's do the on paper one first. It's what we call a substitution method. We did this actually with the 2x2 systems last week, where you go through, you solve for one variable, you plug it into the others. Then, and let me show you what that looks like. So in this particular thing, let me flash it up here. There's my system. I'm going to solve for one variable in one equation, and I'm going to start with this top equation and solve for x. That was just my choice. Okay? And so I just move all this other stuff to the other side. And then I'll take this and substitute it into the two other equations, okay? Which kind of looks like this. I've cleaned it up here, okay, and I'm sparing you some of the gory details. And then I have plugged it into the other, and I'm really sparing you the gory details here because it's a little messy, but you can clean that up. It's okay. It's just a little bit of algebra. And now what I have is a system of two equations with two unknowns. So I've reduced the size of the system by one. And then you just do it again. Okay, solve for, I'm going to choose to solve for y in this equation actually. Since there's no, I'm avoiding fractions is what I'm doing. I'm dodging places that have a coefficient other than 1. So I solve for y here, and then I'll jam this in this equation over here. So that looks like that. Cleaned it up for you. And then you solve for the last equation. It's now a 1-by-1 system, which I know how to solve. Okay. So Z turns out to be 18,800. That's the amount, if I've done things correctly, that's in that shady account out there somewhere. To get the others, just back substitute. And what I mean by that is go back, we had a nice formula for Y in terms of Z, plug Z into it and solve for Y. So Y, the 4% account had $6,400 in it, and then take both of those and plug it back in for X, and that works out to be 4,800. So that tells me the amounts invested in each one. And that's the actual solution. Now very quickly, and I say this quickly because I don't want to get into all the gory details, but I do want to show you how to do this with matrices. Some square matrices will have an inverse that you can calculate with your calculator. And I use a superscript -1 for that. And that acts like a 1. If you multiply these two together, it gives you a matrix with all 1s down the middle. And when you multiply by that, it's like a matrix 1. So what you do is you take the system, you transfer that into a matrix equation. Now, all I've done here is just take my coefficients and move them down. And this times that gives me the first equation and so on. And then you can calculate the inverse of this matrix. You do it on the calculator. Don't do it by hand. We don't know how to do that yet. And then multiply the two. This is all calculator stuff, and it too will give you the answer. Okay, that's the quick way to do it. I'll let you experiment on your calculator with getting that exact answer. I've got some pages that kind of summarize what I just talked about. We'll be right back.